We're going to be doing application problems now. Application problems just means word problems. Notice how here we have a sentence followed by a form. In this case, we have vertex form. With this form, we have to complete the table, we have to graph and answer the rest of these questions. Now, because it is in vertex form, it is much easier for us to fill out the table. Why? Because we always like to have the vertex here in the middle, because it's going to be evenly on the upper side as well as below. So our vertex is 50. Our k is positive. Right now it's -5. It changes to +5. So that's going to be a vertex. Once I have my vertex already, I can go ahead and get my calculator and find the rest of the points. I have -2 parentheses x. It's t, but it doesn't matter if we change it for x in the calculator. X minus 5 parentheses squared plus 50. I'm going to my table. 5 is in the middle, so I'm going to look for 5. Notice how all the numbers above with the numbers below kind of match. Here we have 32, 32, 42, 42, 48, 48. That's what we always look for. That's why the vertex is important for us to put in the middle. So we have 2, 3, 4, 5, 6, 7, 8. We have 32, 42, 48, 50, 48, 42, and 32. I'm going to go ahead and start graphing. I have 232 is right around here. 342 is around there. 448 is a little below 50. 550, 648, and 742. And lastly, 832. So I can go ahead and connect my points already. Remember, we always want that U shape, like this. I'm going to follow and see where, well, I guess we can wait for that when we get here. Our maximum height is just, we've talked about the maximum minimum already. So maximum always has to do with your Y values in application problems. So if you look here, this is our maximum height. At what number is it? It's at number 50. What does this 50 represent? If you guys look here, remember h of t is another word just to say y. So what is y? Is the height in meters. So this should be 50 meters. That is our maximum height. So we have 50 meters here. Then it asks us what is the height of the ball at x equals 3 seconds. I can look at my graph and it's hard to tell, but that's why we need that table, because here we can see that when x, or in this case t, equals 3, y is 42. And we know 42 is meters. Now, when we talk about increasing and decreasing, in application problems, we can't have negative numbers. So we can't have negative here or negative there. Why? If you guys look here, is height. We don't have negative height and we don't have negative time. So we always only look at this quadrant where it's positive numbers and positive numbers. If we look back at our calculator, we can see that 1 is still positive. And then we get here at 0, 0, where it stops. If we go anything past that, notice how we get negative numbers. So we know that if we were to connect this, this belongs there. And if we go to the other side, we should find another 0. Notice how here at 10 equals 0. Anything below that, notice how it's negative, negative, negative. These are positive, but this is negative, and we can't have negatives. So we know that it's increasing. That means increasing, it's going up. At where is it going up? We also know that when we talk about intervals, that is just our x values. And we always use parentheses here. So it is increasing. Notice how here it goes up and then here down. That's why this is a vertex, because it's a turning point. It's going up from where? From 0. It's going to keep going up, up, up until here, which is 5. Same thing here. Interval is our x, decreasing, going down. So it starts here at 5, because this is our turning point, and notice how it goes down, down, down to 10. Again, we have restrictions on intervals for increasing and decreasing because we're talking about word problems. And word problems usually don't have negative. You can't have negative time and you can't have negative height. If we move on to the next question, notice how we don't have vertex form anymore. We have intercept form. That's fine. We can use and we can distribute these right here so we can get it to vertex form. But what I would like to do first is look at our calculator and see if we can find the middle number. Just like we did here for 5. And notice how the 5 was a number in the middle. Why? Because everything else matches. So let's see if we can find that. And if not, we can just go ahead and redo it again. So we have negative 3 x minus 4 x plus 2. I'm going to look at my graph. Right now, nothing looks the same. If we go down, notice how these numbers keep going up. So I'm going to start going up and see if I find anything. Now, notice how the numbers are getting smaller and smaller. If you look here, I notice that there's 2 zeros. All right, and then what's next to it? Both have 15s and both have 24s. We can see that the number that doesn't have a pair is at 127. If we look up, that's negative 21, and this is negative 21. So that means we found our vertex. And sometimes it won't be as easy as it is now, but if it's not, we can just use the vertex formula. We can switch from intercept to standard and from standard to vertex. But for right now, I already have it. If I look here in my calculator, the number that doesn't share, so there's no more 27, it's when 1 is t and then 27 goes here. And I can go ahead and fill out the rest. This is negative 2, this is negative 1, 0, 2, 3, and 4. Negative 2 is at 0, negative 1 is 15, 0 is 24, 2 is 24, 3 is 15, and 4 is 0. I'm going to go ahead and graph them. So I have negative 2, 0, negative 1, 15, 0, 27, 1, it wasn't 0, 27, it was 0, 24. I apologize. 0, 24, 1, 27, and 2, 24, 3, 15, and then 4, 0. Ignore this. Obviously, I can't erase, so I'm just going to go ahead and ignore it. I have this curve right here. Now, what's important right here is to see we have negatives. So this really doesn't matter. You can ignore this if you want. What we want is this right here. I just used it so we can have it perfectly symmetrical. Okay, but you really don't need this. It starts from here. If you guys look here, what is the coin's maximum height? It follows by the same question. Where, at what point is it tallest? If you look at here, but it's so hard to notice where it is. So let's look at our vertex. It's 27. And what does this 27 mean? Well, when at h of x, the height is in inches. So here, this is inches. Then, what is the maximum height of the coin when x equals 1? Well, when x equals 1, in this case it's t, h of t is 27 inches. And then on the coin of interval, and on what interval is the coin increasing? Again, we always have parentheses for both intervals, and intervals means x. So increasing means it's going up. Where is it going up? We don't care about this. Why? Because this is negative. So we're going to start here, okay? And what x value is that? That x value is 0. So we start at 0 going up, and then we go all the way up to 1. And then from 1, notice how we start going down. So we start with 1 here, and we're going to keep going down, 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 down to 4. Notice if you guys look here on this question, notice how we have that 5 on both, just like we have that 1 on both, because that's where our vertex is, okay? And that's very important for you guys to know. Our vertex will be on both increasing and decreasing. For increasing, it will usually be on the right side, where for decreasing will be on the left side. That can change, but that's just something you guys should be looking at, all right? So this concludes today's notes. If you guys have any questions, remember I'm going to be doing a video conference call on Friday from 1 to 2. So if you guys have any questions about this or any other of the stuff that we've been covering in this past week, just dial it and information will be on under announcements. All right, I'll see you guys later.